9:46. Get out your protective glasses at home and join us. It is time for Imagine It. And the chief scientist from the Imagination Station, Carl Nelson, is here. He's got all kinds of flame action. Flame on.
Okay. Every year, there's about 230 fires that are created in homes that the source of the ignition comes from a Christmas tree.
Right.
Now, in the scale of things, that's really not that many fires, but any fire is serious. And I wanted to show you how quickly a Christmas tree that is very dry can go up in flames. And Tony, this is the largest Christmas tree I feel comfortable with having you light on fire, okay? So we're just gonna really quick see what happens here. I'm gonna give you this match, and what I want you to do is bring it down underneath the bottom of the tree.
Okay.
And then let's see what happens.
So potentially if you have some sort of issue, it's a good thing that was as tall as it gets.
So tiny, tiny little 3-inch tree, huge flames. We don't want to set off the...
that's a lot of fuel.
Yeah, we don't want to set off the fire extinguisher or smoke detectors here, but tiny tree. And the reason it goes up so quickly, it's dry, and it has a huge amount of surface area in those little needles.
So there's lots of oxygen between them.
Exactly. In fact, we could even do a really simple example. We're going to do some math here, Tony. Okay, this is a block of wood we want to set on fire. What's its surface area? It's 2 by 2, which is 4.
Yeah.
Times 6. 6 times 4 is 24. Okay? So that's its surface area. Now if I break it apart into a bunch of little blocks, we have 8 blocks of surface area 6. 6 times 8 is?
Lots.
48.
Sure.
It's twice as much surface area. Okay, twice as much surface area. And so that allows the combustion reaction to happen very, very quickly.
Okay.
Okay. And so one place where you really, really worry about that sort of stuff would be in a grain elevator. Okay?
Oh, sure.
So very, very fine powder. And this is combustible. Why don't you go ahead and see if you can light that on fire?
What kind of powder is that?
It's cornstarch.
Okay. Well, I have some creme brulee flamage going here, so pretend I work in a restaurant.
Just go ahead and touch it. Not much is going to happen.
There you go.
Surface area is very small because everything's packed together tightly.
Tight molecules.
Well, tight powders. Next one.
Powders.
But if we were to spray it in the air, you know, something like this, we get that fine mist.
Can I get it?
Go ahead and light your torch, and I'll spray into your torch.
Whoa.
Okay.
Yeah, it's like the hairspray effect.
Exactly. Fine particles. And those would be aerosol particles as well of the hairspray doing the same sort of thing. Now, I'm going to take this away from you.
Yeah, you better.
Those particles maybe 100 microns or so in size. These particles, 33 microns. These are very, very fine powder.
Ooh.
Very, very fine powder.
I'm going to step back.
By increasing the surface area, that might be a good idea. By increasing the surface area, you can dramatically increase the amount of flame that comes out. Right?
Wow.
So one thing to be very, very careful of this holiday season would be keep your tree hydrated. Keep it away from any kind of ignition source. Anything, whether that's a cat under the tree, a match, really fine powder, you know, anything like that you want to keep away from your tree.
What I take away from this is keep Carl away from your tree. But good tips. Thank you very much, Carl. If you want to visit him at the Imagination Station, where it's okay to light things on fire when you are under supervision with the chief scientist, there are the holiday hours. They're closed December 23rd through the 25th.
Correct.
All right. Thanks very much, Carl. That is this week's Imagine It. We're going to turn it over now to Dave with sports.